Hi everybody, welcome back to the Feynman technique. Today we're going to take a look at this integral. I got this integral from another channel. I think it was either, Mathematics MI. Yeah, I think that was the channel I got it from. I'm not sure. I don't know if I can find the video again. Anyway, it was this integral, the integral from 0 to 1 of x squared minus 1 over x squared plus 1 times natural log x dx. All right, so we're going to kind of go back to our original method of solving these types of integrals, and that is to simply reparameterize it. We're just going to create a function of t that's equal to the integral from 0 to 1 of x to the t minus 1 over x squared plus 1 natural log x dx, noting that f at 2 will give us back our original integral, and f at 0 will give us 0. All right, now we'll take the derivative with respect to t, giving us the integral from 0 to 1 of x to the t over x squared plus 1 dx. All right, then we will recognize the fact that the sum as n equals 0 to infinity of negative 1 to the n times x to the 2n is equal to 1 over x squared plus 1 on the interval negative 1 to 1. All right, now let's rewrite our f prime of t using that fact. So that would mean that f prime of t is going to be equal to the integral from 0 to 1 of, let's see, I'm gonna skip some of the busy work steps and just jump right to the final expression. That's going to be the sum as n goes from 0 to infinity. Let's see, we'll have the negative 1 to the n, and then we'll have the integral from 0 to 1 of x to the 2n plus t dx. Integrating this would give us x, it would just give us 1 over 2n plus t plus 1. Okay. So there's our f prime of t, but we don't want f prime of t, we want f of t. So to go backwards, all we do is integrate our f prime of t. So that's going to give us f prime of t being equal to the sum from n equals 0 to infinity of negative 1 to the n times the antiderivative with respect to t of 1 over n plus t plus 1. Well, that's just going to be natural log 2n plus t plus 1. And then, of course, we'd have a plus c over and over and over and over and over again inside our sum, but we can bring it outside the sum as a plus c. Okay. Because a constant time plus a constant plus a constant plus a constant is still a constant. So, all right. So where do we go from here? We need to figure out what our c actually is. Well, I'm sorry, this is not f prime of t. That is f of t. Well, we'll use the fact that f at 0 is equal to 0. That's going to give us 0 is equal to the sum from n equals 0 to infinity of negative 1 to the n times the natural log of 2n plus 0 plus 1, or just 2n plus 1. And then plus c. So c is equal to the negative of this. In other words, and we could use the properties of logarithms to just put it right on the denominator inside our natural log. So we'll write this as natural log 2n plus t plus 1 over 2n plus 1. Now we don't need the c. All right. So there's f of t. Well, f at 2 is equal to I, so we have our answer. That means I is equal to the sum as n goes from 0 to infinity of -1 to the n times the natural log of this thing evaluated at the point 2. So that's 2n plus 3 over 2n plus 1. And that is the answer. Hope you enjoyed that.